Somewhere on Earth right now, someone is being shot, not in a war zone, just an ordinary day, an ordinary place. It happens often enough that researchers estimate over 600 people die this way every single day, source 26. And today there are more firearms on this planet than there are cars, over 1 billion of them, roughly 1 for every 8 human beings alive, source 24, source 25. So how did we get here? Here's the part almost nobody knows. Not one of those guns was ever supposed to exist. The people who started this chain reaction weren't building a weapon, they were trying to build a cure for death itself. Picture this job. You're an alchemist in Tang Dynasty China, and the emperor is paying you, personally, to find the secret to living forever, source 1, source 6. Today you're testing a new mixture. Into the bowl goes a pale yellow mineral, then charcoal, black and crumbling, then a strange white crust you scraped off a cave wall. You grind them together, lean in to check the color, and your workshop goes up in flame. Your hands are burned, your eyebrows are gone. The wall behind you is on fire, and you have absolutely no idea that you just triggered the discovery that would end more human lives than almost anything else ever built. Because that accident wasn't going to stay an accident. Over the next 1,000 years, someone kept fixing it, and every fix built a new way to kill. But before we get into how a failed medicine became a machine, quick word from today's sponsor. Okay, back to the bowl that started all of this. That explosion wasn't rare. Across China, alchemists were blowing themselves up chasing the exact same goal, because the hunt for immortality wasn't a fringe hobby. It was one of the biggest research efforts on the planet, and emperors weren't funding it from a safe distance. When their alchemists produced something promising, the emperors drank it themselves. Several are believed to have died exactly that way, poisoned by their own immortality potions, source 1, source 6. But that bowl held something different. The yellow mineral was sulfur. The charcoal was, well, charcoal, and the strange white crust was saltpeter, potassium nitrate, which forms naturally in caves and damp cellars and in old manure piles, source 6. One of the 3 core ingredients of gunpowder is, quite literally, mineral crust that forms where animals have urinated for years. We know these explosions were happening because by the mid-800s someone finally wrote it down, source 1, source 6. Not as a recipe, as a warning. It described a mixture that scorched hands, burned faces, and set entire buildings alight. The oldest written record of gunpowder in human history is basically one alchemist telling everyone else to stop. Here's why it kept happening. A normal fire has to pull oxygen out of the surrounding air, which takes time. That's why a candle burns slowly. Saltpeter carries its own oxygen locked inside the crystal, so when it ignites, it doesn't wait for air. It feeds itself instantly, releasing a huge burst of hot gas all at once. In open air, that's a flash and a bang. Trap that gas inside a sealed tube and the pressure has to go somewhere, so it blows out the weakest point violently. That single mechanism, a fire that carries its own oxygen, is the entire physical principle behind every firearm ever made. The alchemists didn't understand the chemistry, but they understood they'd found something powerful, and they named it accordingly, Huo Yao. Fire medicine. The deadliest discovery in human history spent its early life filed under medicine, source 1, source 6. For about 2 centuries, fire medicine mostly stayed contained. Fireworks, signal flares, flaming arrows. Then war found a use for it. In 1132, at the siege of a Chinese city called Da'an, defenders facing a Jin dynasty assault held something new, a spear with a bamboo tube lashed to the tip, packed with fire medicine, source 7, source 8, source 9. Put yourself on that wall. An enemy soldier is climbing toward you on a siege platform. You lower the spear, touch a flame to the fuse, and the tube erupts, a jet of fire straight into his face. Historians call it the fire lance. It burned for only a few seconds, but for those seconds, you were holding a weapon nobody on that battlefield had ever seen. Here's the twist inside the twist. Soldiers began packing extra material into the tubes alongside the powder, broken pottery, scrap iron, whatever was on hand, just to make the flame nastier. But afterwards, something strange showed up in the wounds. The flame only reached a few feet. The debris flew much farther, and it did the real damage. Nobody sat down and designed a bullet. The bullet started as battlefield garbage stuffed into a bamboo tube, source 7, source 8. But there was a hard limit. More powder meant more range for the debris, and bamboo can only take so much pressure before the tube doesn't fire, it bursts. Imagine gripping that lance, touching the fuse and having the whole thing explode in your hands instead of firing forward. That happened often enough that Chinese metalworkers were handed a new job: build a tube that won't burst. Their answer was bronze, and the moment the tube became metal, it stopped being a fire lance. It became a gun. We still have one. It's called the Heilongjiang hand cannon, dug up in northern China and dated no later than 1288, the oldest confirmed surviving firearm on Earth, source 10, source 11, source 12. It's a bronze tube about the length of your forearm, weighing 3.55 kilograms. No trigger, no handle, no sights, just a pipe with a hole for a fuse. Suggestion: if usable archival/demonstration footage of a replica hand cannon firing can be legally sourced, cut to it here with on-screen caption 13th century hand cannon reconstruction. If not available, use a slow-motion animated muzzle flash instead. That pipe is the direct ancestor of every pistol, rifle, and musket that followed, and the gun didn't stay in China. Through the 1200s, Mongol armies were fighting from the Pacific coast to the edge of Europe, and gunpowder technology moved with them, source 2, source 3. By 1326, an English manuscript contains the first known European drawing of a gun, a strange vase-shaped pot firing a giant arrow. The artist drew it carefully and labeled almost nothing because there was no word for it yet. Europe took the idea in one direction, bigger, because Europe had a wall problem. Every serious city was ringed in stone that had shrugged off armies for centuries. In 1453, gunpowder ended that era. A Hungarian engineer named Orban had first offered his cannon casting skills to Constantinople itself. The Byzantines couldn't afford him. So he built for the other side instead. An Ottoman siege cannon reportedly over 8 meters long, dragged toward the city by dozens of oxen, source 13, source 14, source 15. Over 53 days, under 2 months, the bombardment cracked walls that had stood for 1,000 years, and the city fell, source 13, source 14. Worth noting on screen or in narration, historians still debate how decisive the cannons actually were compared to Ottoman numbers, logistics, and naval strategy. The popular cannons alone version oversimplifies a complex siege, source 16, source 17. After Constantinople, every fortified wall on Earth was on borrowed time. Cannons could level a city, but you can't carry a cannon into a field. So gunsmiths shrank the barrel down into something a soldier could hold, the hand cannon, a metal tube mounted on a pole. And that created a problem that sounds almost funny today. You couldn't aim it. To fire, you held the weapon with one hand and pressed a burning cord into the touch hole with the other, which meant at the exact moment of firing, you were staring at the hole, not the enemy. The fix arrived in the 1400s, the matchlock. A small metal arm held the burning cord for you, and squeezing a lever swung it down onto the powder automatically. For the first time, both hands held the gun and both eyes stayed on the target. But the matchlock's fatal flaw was hanging right there on the weapon, an open flame. Rain put it out. At night, the glow gave away your position, and every soldier carried that flame inches from his own powder supply. So around 1500, gunsmiths built something that made its own spark, the wheel lock. A wound steel wheel spun against a piece of pyrite and threw sparks into the pan, no open flame required. The problem this time wasn't performance, it was cost. The clockwork mechanism was so intricate that only master craftsmen could build it, at prices only nobility could afford. The answer everyone could afford came around 1610, from a French gunsmith named Marin le Bourgeois, working for King Louis XIII, source 18, source 19, source 20. His design, clamp a piece of flint into a spring-loaded arm, pull the trigger, the flint snaps forward, strikes steel and showers sparks into the powder, the flintlock, cheap, rugged, reliable, and it stayed the standard firearm of the world for roughly 200 years, source 20. But the flintlock still had one massive weakness that shaped how entire wars were fought: loading. To fire one shot, a soldier had to stand fully exposed, pour powder down the barrel, ram a lead ball in after it, prime the pan, and cock the mechanism, a process that could take a trained soldier around 20 seconds. That's 20 seconds standing in the open while an enemy closed the distance. It's a big part of why formations from this era look so strange to modern eyes. Long rows of men standing upright, firing together, then stepping back to reload while the next row fired. The formation itself was built around that one flaw. The man who broke that flaw wasn't a general. He was a Scottish church minister named Alexander Forsyth, and his problem wasn't war, it was ducks, source 21, source 22, source 23. His flintlock had a delay between the visible flash in the pan and the actual shot leaving the barrel, long enough for a duck to see the flash and dive before the shot arrived. In 1807, Forsyth patented a system using a chemical that ignited instantly on impact, with no exposed spark or flame at all. Source 21, source 22. Rain had beaten guns for 600 years. It finally lost, because ducks kept dodging a clergyman. From there, the last step followed almost naturally. Through the mid-1800s, gunmakers sealed the ignition chemical, the powder, and the bullet into a single brass case. The cartridge, source 6, source 23. Loading stopped being a 20-second ritual and became a single 1-second motion. And once loading was instant, you could stack cartridges and fire them one after another. Every revolver, repeating rifle, and modern pistol since is just a faster way of feeding that same brass case into that same metal tube. So here's the whole chain. Alchemists searching for eternal life accidentally built a fire that carries its own oxygen and called it medicine. Soldiers strapped it to spears and built flamethrowers. The junk packed into those tubes turned out deadlier than the flame, so the projectile took over. Bamboo burst, so the tube became bronze. The tube grew into siege cannons that brought down 1,000-year-old walls, then shrank back into human hands, where every version had a flaw. Couldn't name it. Matchlock. Rain killed the flame. Wheel lock. Nobody could afford it. Flintlock. 20 helpless seconds. Percussion cap. And a small brass case finished the job. Nobody planned any of it. It took over 1,000 years, an exploding workshop, burst bamboo, a falling empire, and one very frustrated duck hunter. And now, somewhere on Earth, while you've been watching this, that same basic reaction, the one first triggered in a workshop 1,200 years ago by men trying to defeat death, has gone off again and again, and likely will before this video ends. Source 26. They were looking for a way to live forever. Instead, they handed death its favorite tool. If you want more stories like this, where an accident quietly changed the world, subscribe and I'll see you in the next one.